research. I mean, this was unbelievably elegant research. Basically what they did was this. Remember I told you that how a cell operates depends on which genes are turned on and off? Well, they knew that. So they said, all right, let's take a look at embryonic stem cells from a variety of different mammals. They looked at mice. They said, what genes seem to be on in embryonic stem cells that are different from other cells, even other stem cells? And they narrowed it down to about 25. So they said, okay, let's see what happens if we take a regular cell and put those 25 genes in so that they are turned on. We force them to be turned on. Now, for any of you in biology, transfecting 25 expression promoters into, I mean, that's just outrageous. But they did it, and it worked. It changed the cell to act like an embryonic stem cell. So they said, wow, if we can do it with 25, can we do it with 24? How about 23? Lord, if we're good, will you let us do it with 20? Is this starting to sound biblical or something? Well, in the Bible, he got God down to 5, right? They did one better. They got it down to 4. 4 genes, 4 lousy little genes. When put into a fibroblast, that's a cell that just sits there in your body. It's a structural kind of thing. Helps, you know, run the body and stuff, but doesn't do anything highly special. You got lots of them. So they took one of those and they switched it with 4. That is cool. And so people said, wow. And then, of course, the people who want to do human embryonic stem cell research and cloning said, oh, no, it's not very good. There's all kinds of problems with it. We've got problems like, you know, there's this gene in there called c-MYC. Any biologists here in the room? Are you familiar with c-MYC? This is a gene that's turned on in probably over half of tumors. Okay? So if you're turning c-MYC on in the cell, that could be problematic, you know, because it could make a tumor. And it did. When you put some of these cells in the mice, they made tumors. Well, they're supposed to. Embryonic stem cells make tumors when you put them in mice. That just showed that they were like embryonic stem cells. Okay? So one of the concerns was, yes, in fact, they couldn't say these didn't act like embryonic stem cells because they did make tumors in mice. So they said, aha, see, they make tumors. Well, so what? So do embryonic stem cells. And that's what everybody says is going to cure everything under the face of the earth. So again, it's kind of, you get all this craziness. So what they do? I say, fine. Let's go and see if we can do it without MYC. Because that's a dangerous gene. All right, so they went back and sure enough, they did it without MYC. Now they get fewer cells from the procedure, but they're of higher quality. So in other words, the cells you get are even better looking cells like embryonic stem cells. Now these are not embryonic stem cells. Why? They don't come from embryos. Right? They also may biologically have some differences. But the embryonic stem cells have been touted because they can make all the tissues of the body. So can these. Embryonic stem cells have been touted because they make lots and lots and lots of them. So do these. Right? So many of the very same things people are talking about for embryonic stem cells, these do. So now they can't say there aren't alternatives to human embryonic stem cells. So what's the argument they're making? Well, these are good, but we need human embryonic stem cells too. Now, if you go back 10 years ago, the argument was we have to do human embryonic stem cell research. We have to do human cloning research because there are no alternatives. Well, guess what? Now there are. So they think, well, now we have to do human cloning research and we have to do human embryonic stem cell research because we should do everything. Well, that's a different argument. There are alternatives. What are we talking about here? So here's the situation with these new cells.